Hello, everyone. Let's talk about the final project work, which is about confidence interval and hypothesis testing. For this, I have chosen home prices. Okay, so so in this project work, I want you to I want all of us to discuss about confidence interval and later on formulate a hypothesis and test it. Okay, so let's go for data collection at first. So you can either go to your one of the let's say a real estate magazine and collect 30 randomly selected home prices in a neighborhood, right? Or you can go to zillow.com and search for your county or zip code or your neighborhood, and you can choose any neighborhood you like and select 30 random houses which are recently listed. Okay, so here let me go to zillow.com, which I have already opened up. So let me go to zillow.com. And for this video, for this demonstration, I would just want to go to one of this neighborhood near the West Loop, Potranco Road, and Military Drive West Military Drive. Okay, so let's look onto here. So I'm taking this neighborhood. Okay, so as I counted, there were exactly 30 houses. Okay, including these 4 new homes, 1604 up to 151. Okay, then I collected all this data. So these data, you can tally it with this one. So yeah, and there are exactly 30 houses which has been listed. Okay, so that is it. So that's for the data collection. So this may take you 10 or 15 minutes, right? And what you do is you take a screenshot, right? So take a screenshot of your data and upload the image over here. So let's take a screenshot of this one. So print screen. I think I should do this one. Windows, Shift, and S, right? Okay. Then let us simply go for this these values. Okay, so that looks fine. Okay, so that's fine. And then paste it somewhere over here by using Paint. Let's use Paint to make a new image. All right, so and let me save it in desktop. Okay, so let me write down home prices. Let me put it in desktop. All right, so that's fine. Now in the project work, so please use either Adobe Acrobat or Foglit Reader or any of your choice of your PDF reader, okay, in your computer. So don't use the browser. It may not. So yesterday I showed you in the class that while using browser, it may not allow you to upload the images. Okay, so here you should be able to see this image icon. So click on there and you should see this kind of dialog box where you should be able to browse the file and upload it over there. So I know that I have saved the image in desktop. So which was for JPG, PNG. Okay, so yeah, so just check for the extensions. Okay, yeah, that was PNG file. So this was the home prices that I can see it. Click open. Right. Okay, so looks good, and click on OK. So this is how it should populate. All right, now let's move on. So we have collected the data, and oh, okay, so I need to complete these things. So we know that city is San Antonio, Texas, and zip code. What is zip code? So let me click over here in one of the houses, and it will show me the zip code. So that looks like 78251. That's 78251. Okay, that's fine. Let's move on. So that's the first thing. Okay, now describe the data. So calculate the following. Since we know that the sample, this is a sample of the totality of the houses which are been listed in San Antonio area. So that's a mean. Okay, what is the sample? So that's a sample. Okay, what is the sample mean? So let's go for that. So the sample mean and everything can be found out in this way. So mean. and standard deviation is what we need. Okay. All right. So mean is simply equals to average, okay, from A1 up to D6, right? So that's 30, right? Since we know that there are 6 rows and 5. Oh, there are 4 columns. Oh, okay. I'm sorry. There are exactly 28 houses. 6, 4, 24 houses. Okay, so I'm 6 short of those houses. 6 houses short. But yeah, let's move on. Standard deviation is also similar, equals to STDEV from A1 up to D6. All right. So 305,125. 305,125 is the mean price of the homes. Sample standard deviation is 54,631. 54,631. N is 24, right? Okay. What is the random variable? Random variable is, okay, we can write down X. The random variable is the home prices. I chose. Okay, so that is it. The random variable is the home prices. Okay, estimated the state the estimated distribution to use. You know what is this, right? So I won't be talking about this one. So the distribution is or uniform, okay, or chi-square. So select that yourself. But eventually you will realize what is that. Okay. So error bound. First of all, let us find out the error bound and confidence interval for 90% confidence interval. Okay. So let us figure out the error bound and then we will find out the confidence interval. So the error bound in this case is what? Okay. So we need to figure out the So once you know the distribution that you want, then you should be able to find out the error bound for that. Okay, so 90% means if this is the distribution, okay, then 90% means, so we need to find out these two values, right? Okay, so this one is simply 5%. This one is also 5%, right? Okay, so this is also 5%, and actually they are alpha over 2, right? Alpha over 2. Okay, so you'll be either finding out T alpha over 2 or Z alpha over 2. Okay, right? Okay, so either T alpha over 2 or G alpha over 2. That's what you should find out. So now if it is student's T distribution, if you confirm that this is a student's T distribution, then go for T alpha by 2. Or if you consider that's a normal distribution, then go for Z alpha by 2. Okay, and then error bound. Okay, error equals to what? Plus or minus T alpha over 2 now, or Z alpha over 2. Okay, yeah, one of these two. Okay, times okay, for this one it will be standard deviation divided by root under n, and in this case that will be population standard deviation by n, root n. Okay, so that's the error bound. So that is it. All right, please find that out. And finding out T alpha by 2 or G alpha by 2 is quite easy. Go to GeoGebra probability calculator. You know where to go. Classic hash probability is the tool that we have been using. All right. So if it is normal distribution, then go for this one. And we want, yeah, let's suppose this one, right? So we should go for, yeah, you can see over here, I'm choosing the right hand side, okay, the right tail, and it should be 0.05. Okay, since that's 90% and half of 9% is 5%, right? So that's why we go for that. So this value is 1.6449. Okay, and this value would be negative 1.6449, would be somewhere around here. 1.64499 would be somewhere around here. Okay. All right, so that would be the Z alpha by 2. Now, if it were student's T distribution, then what is the degrees of freedom? Since it is 24, we go for 23, right? N minus 1. And we want this to be 0.05, right? 0.05. So 1.7139. Okay, so that is the t value or t alpha by 2. Okay, so that is it. So either, so this would be plus or minus 1.71, and this is 49 times s divided by root n. Root n is root 24. Here also sigma over 24. Now you go for that. Okay, so find out the error bound. Okay, you should be able to find out the error bound. Okay, now once you have found out the error bound, it is either this one, either the first one or the second one. Then you should be able to write down the error bound and write down the confidence interval. Now, what is confidence interval? Confidence interval is simply, okay, I'll just consider E to be the error. Okay, so confidence interval 90%. Confidence interval will be x bar minus error, okay, x bar plus error. So plus error. Okay, so that would be our confidence interval. Okay, so write that down. All right, and then how much area is in both tails means alpha equals to what? Alpha by 2 is 0.05, alpha by 2 is 0.05, means combine that would be 10%, alpha by 2 is 5%, right? So we can write in that way, but alpha and alpha by 2 is always written in decimal, so write that in decimal terms. Okay, then you might want to write down what is the mean, what is the right confidence interval. This is the sample mean, I think, and this is the sample mean. This is the right endpoint, and this is the left endpoint of the confidence interval. Okay, and confidence level, you already have that over here. Okay, so that's fine. All right. So some students think that 90% confidence interval contains 90% of the data. Use the list of the data on the first page, means this one, okay, and count how many of the data value lies within the confidence interval. What percentage is this? Is this percent close to 9%? So you can find that out easily. Okay. Explain why this percent should or should not be close to 90%. So once you have figured out the confidence interval from here to here, so try to see how many home prices are beyond those 2 points, and then try to see if 90% of the home prices that we have chosen lies within that interval. Okay, and try to explain in your simple words. Okay, write down over here. Okay, describe the confidence interval. What do you understand by confidence interval? Okay, you need to talk about that. Okay, so write down at least 3 or 4 sentences. You can take idea from other sources as well. Okay, and in 1 to 2 complete sentences, explain what this confidence interval means for this study. So what do you think it's telling us about the home prices? Okay, so please write that down. Okay, so you have to interpret this in a very plain and simple words. And now use the data to construct confidence interval. Now you have already known that you should either use Z alpha by 2 or T alpha by 2. So once you have done that, then if it is Z alpha by 2, then find the error bound in such and such a way for 80%. If it is T alpha by 2, then find the error bound for 80%, 90%, and write down all the error bounds. Just write down the numerical value, okay? And its corresponding confidence interval. You write that down. So it will take a bit more time, means nearly, so let me consider this as 5, 10, 15, 20 minutes for this one. Okay, so please take your time. All right. So now you will see whenever the error bound increases, okay, whenever the confidence level increases, the error bound will either increase or decrease, and the confidence interval will either expand or shrink. Okay, so please write that phenomenon and explain why this happens. Okay, write a logical sentence about that. That's it. So this is all for confidence interval. Okay, now for hypothesis testing, I wanted to make it very simple. So let us go in this way. So construct a hypothesis test. Consider the home price to be either 25,000 less or more than the sample home price. So sample mean, this mean would be, mu would be either 25,000 less or 25,000 more. So earlier we got our mean to be 305,000. So let me consider 330,000, or let me consider 280,000. Okay. So let's suppose 280,000. Yeah. That would be the mean null hypothesis. Okay, then it is saying a real estate broker believes that the average home price in your area in average is more than the amount that you have considered. So I am considering that to be 25,000 lesser than the average home price that we got. Okay. So that's why we have $280,000. Then it is saying that the real estate broker is saying that it should be more than 280,000. Okay, so let us go for greater than 280. Okay, so that is it. Then we need to describe what this null hypothesis means and alternative hypothesis means. Okay, so alternative hypothesis is simply telling us that the home prices. Okay, so we were saying that the alternative hypothesis is saying that the home prices in that neighborhood is more than 280,000, and we can similarly write down the the null hypothesis stating that the home prices, the average home price, right? Yeah, average home prices, right? So the average home price is $280,000 in the neighborhood that we chose. We have to figure out the test statistics and the p-value. Okay, so how do we do that? Okay, and you can see that nothing has been stated about the significance level or the alpha value. Okay, so by default, we will consider alpha to be 0.05 or 95% confidence level. Okay, so let's do that. And to find the test statistics and p-value, we go to the web tool, this one, probability calculator, and click on statistics and click on this t-test of a mean. Okay, so this looks fine. And the null hypothesis was 280,000. Yeah, equals to 280,000. And the real estate broker thought that, believed that the home prices in that area should be greater than 280,000. Okay, and the mean was 305,125. The standard deviation was 54,631, and there were 24 homes, right? Then you can see the test statistic is 2.25 and the p-value is 0.017. So let us write that down. So that's 2.25 and 0.017. Okay, so that's good. Okay, now here we can see that the p-value is 0.017. That's nearly 1.7%. Okay, we already know that alpha equals to 0.05. Okay, so here we can say that p-value is less than the alpha value. Okay, since 1.7% is less than 5%. Okay, so that's this. So do we reject null hypothesis or do not reject null hypothesis? Since since p-value is less than the alpha value, so we reject the null hypothesis. Then at a 95% confidence level, okay, we have an evidence that the average home prices in that neighborhood is more than 200,000. Okay, so this is the way how we approach this thing. Okay, approach this problem. Okay, this is it. Now save this file and upload it to the as the submission of the assignment. Thank you so much.